Hi everyone. In this video, I am going to explain about digital IC specification terminology. Here, the digital IC specification terminology is a part of logic families. Actually, from this video onwards, I am going to start the logic families. Logic families are nothing but TTL logic family, ECL logic family, CMOS logic family, MOS logic family, okay, IIL logic family. Several logic families are there. I will explain in the coming videos. Now, in the beginning of VLSI, I told you in the VLSI subject, I told you different types of fabrication technologies like small scale integration, medium scale integration, large scale integration, very large scale integration, ultra large scale integration, and giant scale integration. In order to integrate number of transistors on a particular integrated circuit, a particular silicon chip, we have to follow some logic families. We have to follow some logic family technology. Okay, that means for fabrication we have to use any of the logic family like a TTL or ECL or a MOS technology, or we can also call a CMOS technology. These are the different technologies that we have to use when we are fabricating the number of transistors on any silicon chip, so that this fabrication leads to an integrated circuit IC. Okay, that will be again classified as depending upon the number of transistors we are fabricating in any of these particular different logic sets, logic families. You can call it as small scale integration or medium scale integration or large scale integration, very large scale integration, ultra large scale integration, and even giant scale integration. So this deals with the number of transistors that we are fabricating on a single silicon chip. Okay, silicon die. But what type of technology we are using in order to fabricate? Okay, in TTL also we are having bipolar junction transistors. In ECL also we are using BJT. Whereas in the CMOS and MOS technology we are using a MOS transistors. Okay, MOSFETs. So how many number of transistors that deals with this type of integration technology, and what type of logic technology, logic family we are using that deals with this logic families. Okay. So now in this video, I am going to explain about what are the different specifications, or we can say what are the different terminologies that we have to learn before going into the logic families. So the terminology refers to several terminologies are there, probably 6 to 7 terminology items we have to learn. Among them, first one is threshold voltage. First one is, or actually all these are definitions. I will explain one by one. Threshold voltage. First one is threshold voltage. What do you mean by threshold voltage? The threshold voltage is defined as the voltage at which the input of the gate changes in its state of the output from one logic level to the other. Suppose we are taking a logic family, either it is a TTLC, all these definitions what I am going to tell you, all these definitions are applicable to these logic families, whether it is a logic family related to BJT or a logic family related to MOS transistor. Okay, so threshold voltage is nothing but it is the minimum voltage required. It is the minimum voltage required for the gate to change its state. It is the minimum voltage required for the gate to change its state from one state to another state. That means either from logic 0 to logic 1 or from logic 1 to logic 0. So the threshold voltage, it is defined as the voltage at the input of the gate of the gate causes a change causes a change in the state of in the state of the output from the output from one logic level to one logic level to other. Okay, so as I said, it is the minimum voltage required for the gate to change its state. Simply I can say it is the minimum voltage required for the any type of logic gate to change its state from logic 0 to logic 1 or logic 1 to logic 0. This is what the threshold voltage is. And the second definition is propagation delay. Propagation delay. So propagation delay, by seeing the name we can understand that it deals with the time delay. It deals with time delay. So propagation delay is nothing but the propagation delay of a logic gate is defined as the time taken by a pulse to propagate from input to the output. Okay, suppose you are having a circuit, any type of logic circuit. Okay, that may be with a TTL or any type of logic family. This circuit is having the input, that is a pulse or whatever it is. When you are taking the output, what is the total time? Suppose at t is equal to 0, I have given this rising edge. But the output is occurred after some t is equal to 5 nanoseconds. It is at t equal to 0. Input actually we have given at this particular point, but it has taken some amount of time like 5 nanoseconds to start in the output. That means the time taken by the output, the time taken by the signal to reach from input to the output is the propagation delay. Is the propagation delay. That exactly we can define it as the propagation delay. The propagation delay of a logic gate is defined as the time taken by a pulse to propagate from input to the output. From input to the output. Hope you understand. Okay, so the time taken by the logic gate, the time taken by the pulse, actually the time taken by the pulse to travel from input to the output through a logic gate, it is nothing but propagation delay. And the third one is power dissipation. Power dissipation. So this particular parameter or metric deals with what is the amount of power dissipated while we are operating with the logic gate, while we are operating with a logic circuit. So the power dissipation of a logic gate is the power required by the gate to operate with 50% of duty cycle at a specified frequency and is expressed in milliwatts. Okay, the power dissipation of a logic gate is the power required is the power required by the gate to operate with 50% with 50% duty cycle at a specified frequency and is expressed in terms of milliwatts. Okay, suppose if any gate is having power dissipation, like in TTL for example, I can say for example in TTL we are having, TTL has a power dissipation of TTL has a power dissipation of 10 milliwatts. TTL logic family. Every logic family is having different power dissipations. TTL has one type of logic power dissipation. ECL has one type of power dissipation, like that. Okay. So in the next video, I will explain the comparison charts of all these. TTL, how much is the power dissipation? ECL, how much is the power dissipation and propagation delay. Likewise, we are having a table there. I will discuss. So okay. So power dissipation is nothing but it is a power dissipation or whatever the parameter you are going to deal with, all these parameters you should study with respect to the logic gate. Okay, so the power dissipation of a logic gate is defined as the power required by the gate to operate with a 50% duty cycle at a specified frequency. That means you are not giving unsymmetrical or any type of waveforms, you are giving a 50% duty cycle where the on period is equal to off period. 50% duty cycle means exactly it is a square wave. Such type of, when you are giving such type of waveform, the power consumed by that particular device is nothing but your power dissipation. Now Fanin, very important metric or definition you are going to see is Fanin. So Fanin, the Fanin of a logic gate, the Fanin of a logic gate is defined as the number of inputs that the gate is designed to handle. So fan in is nothing but, fan-in of a logic gate is defined as the number of inputs that a gate is designed to handle. Suppose I am taking an AND gate. Okay, so AND gate may be a 2 input AND gate, 3 input AND gate, 4 input AND gate, or it may be in general n input AND gate we can consider. So what is the maximum limit of the size of n? Okay, definitely there should be some limit in any type of logic circuit, any type of logic gate. You cannot give whatever extent, you cannot increase whatever extent you want. Okay, because the gate must have a capability to withstand the number of inputs that you are giving. Okay, so there should be a limit on the number of inputs. So this is called fan-in. Fan-in is nothing but it deals with the number of inputs you are connecting at the input of a gate where the gate can handle. Okay, now opposite with this fan-in, which is fan-out. So what do you mean by fan out? The fan out of a logic gate, the fan out of a logic gate is defined as the maximum number of similar gates that that the output of the gate can drive without impairing without impairing its normal operation. Its normal operation. Okay. In the previous case, I discussed about the number of inputs. Now, okay, this is the number of inputs we have. The output of this particular gate can be given to how many number of inputs, how many number of other circuits here. Okay, suppose I am having another gate here, here, and here. How many number of other logic gates can be applied with the same output coming from this particular gate? Okay, here there is a limit. Here there is a limit. This deals with the fan out term. So fan out deals with the number of outputs that a gate can drive. Suppose if you are having 10 number of gates, the gate which is connected here, it can handle only 10 number of gates. If you are giving 10 plus 1, then the output may not be sufficient to drive the other logic circuits. That may be diminished, and you can treat the logic 1 as logic 0, or logic 0 may not be recognized as a perfect or proper logic 0, and logic 1 is also may not be recognized as a proper logic 1. Okay, so that's why there should be a limit. So this is given by the term fan out. And another term, another word or a specification is noise margin. Noise margin. Noise margin is the maximum noise signal. It is the maximum noise signal that can be added to the input signal of a digital circuit of a digital circuit without causing an undesirable change in the circuit output. So it is the maximum noise signal that can be added to the input signal of a digital circuit without causing the desirable change in the output. Suppose I am having a logic gate or any type of logic family. I am giving the input. In the logic families, we are having some logic levels. Suppose if I am taking a CMOS logic family, 0 to 1.5 is treated as logic 0, and 1.5 to 5 volts is treated as logic 1. If any input voltage is in the range 0 volts to 1.5 volts, that may be treated as logic 0, and 1.5 volts to this 5 volts is treated as logic 1. This is the noise logic level. Now if I am having any additional voltage which is the noise that can be added to this particular logic 0 level or logic 1 level, that should not violate the characteristics of this logic 0 and as well as logic 0, logic 1. Okay, so whatever the maximum voltage that you get, the maximum noise that can be added, that should not change the logic 0 and logic 1 status. And last one is speed power product. Sixth one, speed power product. Speed power product. The speed power product is the product of the speed power product is the product of average propagation delay in terms of nanoseconds. Propagation delay is always measured in terms of nanoseconds, and the average power dissipation measured in terms of milliwatts of a logic gate. So here in the definition heading itself known as speed power product. So it is the multiplication of two factors. One is the delay, another one is the power consumption. So propagation delay and power consumption, we are multiplying these two to get this factor. So it is the figure of merit of an IC family. We can also say it is the figure of merit of IC families. Okay, so this is about the digital IC specification terminology.